trigonometry, probably the most important formula is the sum and difference formula, because all the trig formulas can arrive from it. I showed you the basic definitions yesterday, but the actual identity proofs are all coming from what you're about to see. There's a few things you got to remember. One is that if you have a point xy, what did we call that point in trig talk? Cosine theta, sine theta. Now, what if theta was t? Then you'd call it cosine t, sine t. What if theta was t plus cosine? Then you'd call it what? Cosine t plus theta, sine t plus theta. So the idea is that this angle is pretty versatile. You can put any angle you want. Is that all right? Okay. The distance formula is the change in x squared plus the change in y squared. You remember that. And sine squared plus cosine squared equals 1. All right, so here we go. First thing we're going to do is we're going to use the unit circle. This point here is over 1 up 0. So that is nice. And then I'm going to come all the way over to here, and I'm going to call this arc length, all the way over to here, arc length A. That's right here. So if this is arc length A, what is this value here going to be? Something A, something A. What is it? What's the point going to be? Thank you. Cosine of A, sine of A. That's not hard, is it? That's okay. And then for this one, I'm going to give it arc length B. So from here, the chain is going to go all the way to here, B. So what's this point? Cosine B, sine B. So you're right, Kurt. This is easy so far. Now, since these are 2 points on the circle, I'm going to imagine that they're anchored to the circle, and then a chain is going to be connecting these 2. And with these chains, I'm going to pull cosine B, sine B to the right, and then that's going to move A, cosine A, sine A up. I'm going to just keep pulling it along this circle all the way until it gets down to here. And so the arc length B, cosine B, sine B is down here at 1, 0. This is the point I'm interested in. If this out to here is A, and this to here is B, what is this length on the circle? A minus B. You get that? So if this were 20 and this were 15, it would be 5. 20 minus 15. So then this point, what will this point be then? Cosine A minus B. I thought that's what it was doing. Sorry about that. That looks so weird. We're having some real issues here with the smartboard. Sorry about that. Cosine A minus B sine A minus B. So there you have it. You have 4 points, and these points have a distance 1 between cosine A sine A, cosine B sine B, and a distance 2, cosine A minus B, so on, 1, 0. Distance 2, what can you tell me about distance 1 and distance 2? They should be equal. So write that down. Here's where the fun begins. We're going to take the distance formula between for D1 and the distance formula for D2, and we're going to set them equal to each other, and this is going to take some space. Now, if I'm really gifted, I can get all of this in one row. On the smartboard, we'll see how that goes. So this is like x2, y2, and this is like x1, y1. So the distance formula says that if you take the change in x squared plus the change in y squared, you're going to get the distance squared. So I'm going to do that. I'm going to take this x minus that x. cosine A minus cosine B. And then I'm going to square it. And then I'm going to add sine A minus sine B. And then I'm going to square it. Now this whole thing is square root. On the other side, I'm going to take this one I'll call x2, y2. This one I'll call x1, y1. And you see how when I do x2 minus x1, I get cosine A minus B minus 1 squared plus sine A minus B minus 0 squared. Exactly. What am I trying to prove? These are both square roots. This is square root and this is square root. To get distance 1 between these 2 points and distance 2 between those 2 points. The thing is, if they're both square root, could I square both sides and lose the square root? So I'm going to do that. It's okay. All right, so now what we're going to do is expand this. So back in the old algebra days, you knew how to go cosine A minus cosine B times cosine A minus cosine B. You knew how to do that. You knew how to FOIL that out. These two, these two, these two, these two, right? So let's do it. Cosine times cosine is cosine squared A. Then you're going to have minus cosine A, cosine B, minus cosine A, cosine B. So we're going to have minus how many cosine A, cosine B's? 2 of them. Good. Then it'll be minus times a minus, which is a plus. Cosine B times cosine B is plus cosine B squared. And just a quick reminder, cosine B squared is the same as cosine squared B. Do you know why we write it that way? The books publishers save money on not having to print and taking up space with these extra parentheses. This is this cheaper form. Yeah.
Can you just clarify what the middle terms are?
Absolutely. Cosine A, cosine B times 2, because there's 2 of those. Oh, you guys are doing great. Well, then we just keep going. Keep going across here. I'm going to use a different color this time because I think that it helps. This will be sine squared A minus 1 sine A sine B, another sine A sine B, so it'll be minus 2 sine A sine B. And then it'll be plus sine squared B. Running into a little room problems. That's all right. We'll fix it. There we go. Next, now we're going to, hi.
Sorry I'm late. I was at the
Oh, that's no problem. So the next thing that we're going to do is we're going to expand this one. Now this is going to be cosine squared. Pick the wrong color. I want a good color. We don't have yet. We don't have red. Cosine squared A minus B. Then there'll be 2 of these, minus 2 cosine A minus B. Minus 1 times minus 1 will be plus 1. Now you want some good news?
Yes.
What's sine A minus B squared minus 0? Yes, so all you have to do is just go plus sine squared A minus B. Minus 0, it's going to disappear. And there it is. That's the whole thing multiplied out, FOILed out. Looks horrible, looks terrible, but let's see if you can look at that and come up with some way to make it look. Yeah.
There's a bunch of cosine squared plus sine squared.
What's cosine squared A plus sine squared A? 1. What is cosine squared B plus sine squared B? 1. What's cosine squared A minus B plus sine squared A minus B? 1. Okay, so what you're left with is 1 minus 2 cosine A cosine B plus 1 minus 2 sine A sine B, and then this is going to be 1 equals 1 minus 2 cosine A minus B, and there is another plus 1 in here. So this guy in green plus this one in purple plus the other one in red. And can we lose anything?
Yeah.
What can we lose, Kurt? Yeah, these two ones can cancel out, and these two ones can cancel out. And so what you'll be left with will be negative 2 cosine A cosine B minus 2 sine A sine B equals negative 2 cosine A minus B. What are you going to divide both sides by? Negative 2. Love it. So your final answer, your final result is going to be cosine A minus B, that's this part, is equal to the cosine of A times the cosine of B plus sine of A times the sine of B. That is the formula that we're trying to get. That is the difference formula. Now, I asked a few years ago, is there any way that any of you could figure out that we could come up with a way to remember this formula? Because it's a hard one to remember. Cosine A, cosine B, sine A, that's hard. So for years, we never found a good way to remember it. And then this student from, I think she was from either Colombia or Brazil. I can't remember what. She was from South America. She said, oh, we have that one down. This cosine A minus B is CoCo-CC. So we're going to remember this as CoCo plus CC. That's the cosine A minus B. And it is addition. The tricky part is if this is minus, this will be plus. Any questions on? So there's more that you can do with this. We just proved that the cosine of x minus y, what was that again? What was the shortcut? Co first times cosine of the second. If this is minus, this will be plus. Sine of x, sine of the second, y. All right, we're going to use this to figure out all of these. Okay, and that's your homework, is to do that with this, just these 8. 1, 2, 3, 4, here, and these. Now I'm going to give you a little hint on this one, sine x minus y, which I'm going to prove for you tomorrow. But this one's the sine of x times the cosine of y minus the cosine of x times the sine of y. What do you think our Spanish friends, how would they refer to this one? Seco cosi for sine. And you notice that the minus lines up with the minus this time. Cosine, they're opposites. Sine, they're the same. So you're going to do these 4, and you're going to do these 4, and that's it for tomorrow. But I'm going to give you a hint. Cosine of negative x is the cosine of 0 minus x. Do you agree with that? And the cosine of 0 minus x, this is my a, and this is my, oh, a. Yeah, a and b. This is like a and b. So the cosine of the first, cosine of the second. I should have used a and b's here. because I used x's here. But I'll let you figure that one out. And then for this one, it's the cosine of x minus negative y. So this is kind of your A and this is your B. So those are the things you're going to need to know, and I'll let you creatively figure out these other ones. Hold your arms out like this to your right. Go up theta. Go down theta. What is true about cosine minus theta and cosine theta? Same. What about the signs? Opposite. So somewhere on the margins here, right, cosine x negative x is equal to the cosine of x. And you're going to prove that right away here. And then you'll also need to know sine of negative x is the opposite of sine x. You're not going to know that yet, but you're going to need it for this. And then everything should be good. Should be great. So you're going to do those 4 and these 4.